All right, to solve this problem, what I would do is, now that I've plugged this into the calculator and found a 0 at x equals 5, I would go ahead and use synthetic division to find out what I get if I basically factor out x minus 5. And so I'm going to use 5 here, because remember we use the 0 there, not the corresponding factor. We drop down the 4, and then we multiply 5 times 4 and get 20. Then we add the negative 28 and 20 and get negative 8. Now we multiply 5 times negative 8 and we get negative 40. And we add 46 and 40 to get positive 6. And then we multiply 5 and 6 to get 30 and add to get a remainder of 0. So basically what I have found here is effectively that if I have factored out x minus 5, I am left with 4x squared minus 8x plus 6. Now this is where I'm kind of noticing that I have this common factor here, and I actually could have seen it back here if I'd wanted to as well. All of those are divisible by 2. So I'm going to factor out the 2 and just put it in the front just to kind of make my life a little easier, so there's smaller numbers to work with. Now at this point, if I saw on my calculator screen that I could have seen some other zeros, then I would be tempted to try to factor this. On my calculator screen, it didn't look like there were any other nice zeros there. My prediction is this isn't factorable. So I'm going to go ahead and try to find out what the zeros are. Instead of by factoring, I'm going to use the quadratic formula to try to identify any remaining x values that will give me a 0. So now I plug it in. I say a is 2, b is negative 4, c is 3. So then I do negative b, which is negative 4 is positive 4, plus or minus the square root of b squared, which is a positive 16, minus 4 times a times c, all over 2 times a. And that was 4 plus and minus square root of 16 minus 24 all over 4. And what that was going to help me with is recognize that I have now got a 16 minus 24 underneath the square root, which is going to actually turn into a negative 8. So I'm just going to make that a negative 8 right now. And over 4. Now, I would like to try to tidy this up as much as possible. So one thing I could do is reduce my radical and also deal with the fact that there's a negative under there. So I'm going to factor out the biggest perfect square I can from 8, which is 4. And then I'm left with 2. And then I'm going to keep the square root of negative 1 over here, which is going to turn into an I. And now from here, that becomes 4 plus or minus 2 square root of 2 times I, all over 4. Since I can divide each of those coefficients, 4, 2, and 4, by a 2, I'm going to divide each of those by a 2. And that is going to leave me with my final answer, which is basically, I'm just going to bring it up here because I'm a little out of space. X is either equal to 2 plus square root of 2i all over 2, or x is equal to 2 minus square root of 2i all over 2. And so my 3 zeros are the 5 that I found at first and these other 2 as well.